Okay, so we are on page 127, and we have 4 equations. It says 4 physicists describe the amount of a radioactive substance, Q in grams, left after T years. All of those equations are in different forms, but they are equivalent, okay? We need to use our exponent rules, okay? Our exponent rules. So one of the rules that you might be using says that a to the b power times a to the c power. Does anybody know this or recall this by chance? A to the what? What did you say? Not quite. You're close. Yes, a to the b plus c power. So when you are multiplying, listen, when you are multiplying 2 powers that have the same base, you keep the base and you add the exponents. Okay? That's one of them that you might use. The other one would be in the form of a to the b power and all of that taken to the c power. So a to the b power and all of that raised to the c power. Does anybody know what that would be? I know this is a long time ago. Did you even do this? Yes. Probably in Algebra 2. A, B, C? What do you mean? A, B, C like this? A to the B, C, yes. So if you have a to the b power and you raise it to another power, you multiply the b and the c together. Okay? All right. So since these equations, they're all equivalent, we are going to use mostly those 2 exponent rules to try to find that they are equivalent. Anybody have any suggestions or what worked? Ooh, I hear some talk. Set them all equal to each other. Well, which ones would you like to start with? Hey, guys. The bottom 2. Okay. So, how about we do a to b, a to c, and a to d? Let's do this first. So let's start with this one as our first. This one is the first, okay? So we're going to say Q equals 300 times e to the negative 0.0577 t power. And if you follow this, that is 300 times e to the negative 0.0577 to the t. Like e raised to that and then raised to the t. So I'm separating them. I am going in reverse order of this last exponent rule, okay? On your calculators, I want you to take e to the negative 0.0577 and tell me what you get.
What does that say?
300 times e to the negative 0.0577 t. And this e is, if you hit second and the natural log, so it's in the first column, 3rd row down. That's your e to the x. So what are you getting there? Okay, you should be getting, for this part, 0.9439, and then that would be also to the t power. Did everybody get that? Okay, so here's what you need to do on the calculator. You need to take second, and you need to hit the natural log key. And then you put in what? Negative 0.0577, and then enter. I believe that should work correctly. Okay, then that should give you this 0.9439. Well, what is that exactly like? Which of those other equations? It's exactly like the third one. So this first one, just by separating our two exponents and looking at this power by itself, we can say that 1 and 3 are the same. Okay? All right. So let's go now to another one. I'm going to start with the same one. Are there any questions on that first one? Anybody still having some problems? Enter. That's enter. You know, enter. All right. Now, let's go from the first one. Let's try to get to the second one. So, 300e to the negative 0.0577t. And I want to try to get to 300 times 1/2 times t to the 12th. Okay. So I'm going to say these are equivalent in this case. Not t to the 1/12, t divided by 12. All right. Any suggestions on this one to get the first two to be the same? Brian, are you with me? Okay. So what if we separated this and said 300 times 1/2? What is this raised to right here? What are those two things? It's t divided by 12. How else could I represent t divided by 12? How about if I tried to multiply? What could I multiply? 12? 12 times what? Gives me t over 12. I don't think we're looking for 12. I just want to know, how could I rewrite this? So if I said, I don't know, if I said w divided by 3, how could I rewrite that times w? Yeah, 1 over 3, right? So let's call t divided by 12 1/12 times t. Let's separate those, okay? So I want you now to take 1/2 and raise that to the 1/12th power and tell me what you get. Take 1/2 and raise it to the 1/12th power. You have to do the caret. So 0.5 or 1 divided by 2. Huh? Well, it depends. What'd you get?
I got 9.94387.
Okay, you got 0.94397.
Were we not supposed to put 300?
You didn't have to.
Oh, that just gave me like a different number.
Right, but look what happened. That takes me to these first two. Guys, take a look. So when I did that and rounded it, it takes me back to this 0.9439, which we just did up in number 1. So I went from number 1. Okay, is he supposed to go now? Okay.
Does it have a time on it?
It does not. It just says 6 periods. Yeah. You go, Justin. Yeah. Leaving time 1:17. You're going to guidance. You need guidance, I guess. Okay, so this takes me from 1 to 2 to 3. Okay? 1 to 2 to 3. And the last one. Yuck. This one is the worst. So 300 times e to the negative 0.0577t. We want to take that to this one over here, which is 252.290 times 0.9439 times t minus 3. Now, take a look at this exponent, Martavius. Take a look at this exponent, t minus 3. If I am subtracting those, what does that mean? How could I rewrite that? Because we just said over here, if we're multiplying powers, we add them. So if I'm subtracting, what operation do you think I could be doing with those? Dividing. So this I can rewrite as 252.290 times, this is 0.9439 to the t power divided by 0.9439. Give me a second. To the third. Okay. And how does that help us? T minus 3. We're dividing, so it's t minus 3. Or okay. T to the 3, or instead of doing it that way, I think I got it now. 252 times 290 times 0.9439 to the t times 0.9439 to the negative, how does that go? Negative exponent, negative 3. So take 0.9439 to the negative third power. Tell me what you get.
35.
35 exactly? Okay, are you sure?
No.
0.9439 to the negative 3 power. What are we getting? Hello? Yes, 0.9439 to the negative 3 power. 1.1891. All right, so that is a number. I want you now to multiply that by 252.290. And hopefully it gives us 300.0009 or something. Please say yes. Guys, why is only one person doing this multiplication? I'm telling you what to do. I just need you to calculate it. So 252 times this gives you 300 rounded times 0.9439 to the t power, which takes us back from 1 to the fourth one to show us that it's similar to the second one. Okay? So it is doable, but you have to use the exponential rules, okay? I don't believe you're going to have to do anything like this for your project. But we wanted to show you that you are capable. You can do it. I am recording this so you can go back and look at it after today, okay? So, I will have it. I will have it. So, what do each of these show you? What are the important aspects that we are given or told from each of these different points of view? These different equations. So, in equations 1 through 3, what does that tell us? In general, what do they all have that are the same?
300.
And what is that, 300?
Initial.
Right, so in equations 1 through 3, we can tell that our initial amount that we started with is equal to 300, okay? 300 what? We don't know, but it's 300. What else can we determine, if anything? What else can we determine, if anything? Look at equation 3. So this one right here. What can we determine there? What do we call this right here? You could say actually 3 and 4. What do we call that? No, what do we call that? First of is it growth or is it decay?
Decay.
How do we tell?
Is it not, because
Is it more than 1?
No.
No, remember it's always 1 plus or minus your rate. And because that is 0.9, that means it must be minus the rate. So we're talking about decay, okay? What is this 0.9439? What do we call that? It is a decimal.
Growth rate. The rate or decay.
It's not the growth rate in this case,
it's the decaying rate.
but is it a rate?
Change of.
Factor. So this is a decay factor. The decay factor is 0.9439. What else can we tell from 3 and 4? If we know that is our decay factor, what else should we be able to figure out? What? What else can we figure out? What is our decay rate? How would I figure that out? Eventually, but remember the factor was 1 minus something, and that gave me 0.9439, right? So to solve for R, you can subtract 1, and then negative R gives you, what's 1 minus 0.9439? 1 minus 0.9439. Point 0.0561. So if negative R is that, positive R is going to be 0.0561. And if I change this into a percent, so my rate is 5.61%. Okay. The other thing that we can tell is that this was per month, wasn't it? If I look at equation number 2, I have 300 times 1/2 t divided by 12. Okay? T divided by 12 means I'm looking at it monthly. Number of years divided by 12, looking at it monthly. And so in 1 year, well, okay. In 1 year, it's going to go down to 1/2. This is radioactive, so it is decaying. Okay? So in 1 year, the decay, the amount left, no, that's the growth. That's the decay factor. Yes.
I can't do a problem like this on
It's not, you're not having a test. Remember, it's a project.
Okay, don't put it on the final.
So 300 times 1/2 is the 150, which is half of what we started with. So in 1 year, the decay is half. We've reached half of our material. Okay? We've reached half of our material. All right. This was a doozy today, I will tell you.
Too much for no reason.
It was a doozy. Always is a very strong word. Tomorrow is going to be much simpler than this. You'll think it's cake compared to this. Yeah, because I went to Miss Bieshke. I was like, they're not going to know how to do any of this.
Yep, especially not that.
I know, that was crazy. But using your exponential rules, I mean, it kind of does make sense. Yes,
No.
it's a little far-fetched. I mean, to remember stuff from 2 years ago. But it is possible. It is possible. And because we are not spending a ton of time on it, we're not expecting you to know how to go back and forth between these. We just want to show you that it is possible. Okay?
No, so this won't be on the test.
It's gonna be on the test. What? What does the final look like? Some of it's going to be multiple choice. Some of it's going to be short answer. Multiple choice is going to be on the computer. I don't know about mainly.
Last year we did like 2 or 3 more problems.
I think you'll have more than 2 or 3. All right, so there is no new homework, but you should be working on 7.1, 7.2, and 7.3. And I told some of you I would help you with 7.3. So we'll probably try to do that tomorrow, because tomorrow's lesson is much shorter and much easier. Huh? Yeah, 7.3. We'll talk about 7.3 a little bit. Yes. I stay after on Tuesdays and Thursdays. Yes. So keep working on that homework. Again, guys, listen to me. The best way to boost your grade is to redo tests. If you have an extremely low grade, you need to redo the test. But you also have to make sure you've done all the homework in that section. That's one of the criteria. Need to retake a test, do the homework for that chapter, that section, make corrections, and schedule a time. Don't forget also, May 12th is the last day to turn in any late or missing assignments. Okay? All right. Yeah.
Is this the end of